Welcome, everybody. Happy Saturday. Now, we wrapped up our week-long series of Tech Talks yesterday, so you all know me by now, but just in case you don't, my name is Aditi Joshi, and I am your host and moderator for the Tech Talk series, as well as today's technical dive. We kicked off the hackathon last night, so hope everyone has started to hack away and is almost done with team formation. Now, on Tuesday, Dr. Ken Mandel from Boston Children's gave you the history behind healthcare data interoperability and how important it is. And I think we've all felt that pain. And it's really been a long road to get to where we are today. And there's a huge amount of work that's been done at Boston Children's to get us here. And they continue to do some really groundbreaking work. So what I wanted to do was a technical deep dive into the Smart Markers framework, which captures patient-generated digital endpoints and really focus on the FHIR aspects. Now, see how FHIR has really been this common theme throughout the week? So I've posted several resources for you in the Discord channel, so I want to make sure that you go check those out. There's also a FHIR certification that HL7 is offering. I think it's starting this year. And also on Discord is a very technical tutorial in great detail that really walks you through the Smart Markers framework. So take your time to kind of familiarize yourself with that. Now, we announced this at the hackathon kickoff ceremony last night, but just a quick reminder that Boston Children's Hospital is offering a prize at the hackathon for best use of smart markers, similar to what Stanford Biodesign team is doing in terms of the prize for best use of Cardinal Kit. Now, it includes being showcased on their app gallery, which is always a great resume builder and a perfect way to showcase your skills. So I highly encourage you to explore those options. Okay, with that background, let me introduce you to our speaker, Dr. Raheel Sayeed. Now, Raheel is an informatics researcher with a focus on personalized digital health tools and their inherent role in clinical decision-making. He's trained as a physician, but Dr. Sayeed is now a postdoctoral fellow at Boston Children's Hospital in the Computational Health Informatics program, and he's also a fellow in pediatrics at Harvard Medical School. He designed and developed the Smart Markers framework that integrates patient-generated health data with clinical or research enterprises using industry standards of SMART on FHIR. And he's routinely engaged with collaborative initiatives of mobile health, digital trials, HL7 FHIR, and Argonaut to advance patient-centered care. With that, I am going to bring Raheel to the virtual stage. Welcome, Raheel.
Thank you. Thank you very much for having me. I'm very excited to be here. Strange in the pandemic era to have this. I usually go to these events live, but this is my first time at the MIT Hacking Medicine Build-a-thon. So really excited to be here.
Well, they are the granddaddy of all hacks, so welcome. All right, I'm going to give you the stage, so it's all going to be you. I've shared your slides, and I'm going to go backstage, and it's all you now.
All right, thank you. Okay, so let's get started. I am, of course, Raheel Sayeed. I'm a fellow at BCH. Today, I'll be talking about Smart Markers, which is a framework for capturing patient-generated digital endpoints. Specifically, when we are talking about patient-generated health data, we are referring to either patient-reported outcomes, which are surveys, or any health metric that is self-generated, either using mobile devices or connected peripherals, for example, Omron or blood pressure, or wrist watches for heart rate and activity. While they combine together to make the whole category of patient-generated health data, a subset of them, which is specifically the PROs, have gained a lot of recognition in many recent studies, which have actually called for their routine use in clinical care and not just in research. They refer specifically to the health status report obtained directly from the patient without clinician's interpretation. Usually, they are validated questions that measure either quality of life, symptom, or physical function, like Oxford knee scores, or even NIH's new PROMISE instruments, which are a whole new domain of computerized adaptive questionnaires for a very large number of functional and symptom assessments. While these measures have been in use in some capacity, they have not been widely adopted in routine care. And if they are, they might be disconnected from the point of care interfaces. And finally, there aren't many modern approaches to adopting all kinds of health data like activity, heart rates, ECGs. Today, you will see some questionnaires that are built into the EMRs. So as I talk about this, you may be getting a view that this is very much an effort to integrate patient-generated data, not just in research, but actually in routine healthcare, where it becomes a scalable service that is adopted by all kinds of health systems. So with that in mind, Smart Markers was really built to streamline capturing such PGHD, not just in the clinical research domain, but also in routine clinical care. It is a software framework that allows developers to rapidly build custom apps for bringing PGD to the point of care. And exclusively it uses interoperable standards and reusable technologies. Earlier this week, both Graham and Ken talked about the whole genesis of standards in the healthcare industry per se. Graham talked about FHIR. He's essentially the father of FHIR. And Ken talked about the SMART specification, which actually came out from our computational health informatics program. It is essentially combined together. SMART and FHIR is a specification that allows third-party apps to securely access the EHR data using open standards. It is basically a health-specific implementation of OAuth 2, which is very famous and almost everybody is familiar with it. And now there's actually an emerging ecosystem of third-party apps that work in the EHR, two of which are actually shown here. One is BP Centiles and the other is in some form of production these days, which is a lipid profile check for all kinds of patients. So these are apps that can be launched within the context of an EHR as the practitioner is viewing the patient's chart. Now, before we get true technical into Smart Markers, let's take an overview of what an interoperable architecture looks like. And that is really the key to this framework, which is to only rely on standards. And that essentially is FHIR, it is SMART, and anything that is scalable and web-friendly. At the center of this architecture, which is, of course, a highly simplified version, is the SMART and FHIR compatible EHR. There is a PGHD metadata registry within this EHR, and I'll come to that in the next slide. At the point of care, which is here, in clinics or waiting rooms, there are apps for practitioners that can dispatch data requests to the patients. And on the other side, there are patient-facing apps that respond to those requests by generating data and reporting back to the health system. So that is essentially the complete flow of interaction for PGHD from the practitioner side and the patient side. Smart Markers is for building both these contexts, which is apps for both practitioner-facing and patient-facing contexts. While here I'm referring to the EHR as a FHIR server, this could be any FHIR RESTful service that is either provisioned in your institution's private virtual machine, like we do at BCH for research, or using a cloud vendor's managed FHIR APIs. And sure, last week we have heard Google's great healthcare APIs. So anything that is a FHIR RESTful compatible service should be readily usable with the Smart Markers. I talked about PGHD instrument repository, which is basically a set of FHIR resources hosted in the EHR or the FHIR server. While this is not entirely necessary, but having a registry like this makes PGHD capturing an institution-wide service, which is ultimately our goal and vision with something like this, which is that there should be capability to get patient-generated data and have it integrated within a hospital's EMR as throughout its institution, and that is available for all its doctors and all its patients. This is an instrument repo like this is helpful because a bunch of practitioner-facing apps can look up available list of instruments that they can send a request for to their patients. It is a means essentially to digitally identify what device software was approved for PGHD use. And that can change and can be variable depending on the institution. Some institutions may not have all software and devices that are approved for capturing PGHD data. In this approach, we try to codify, and actually propose to codify all kinds of software and devices, and then have it embedded within the FHIR-based repository using FHIR resources, essentially as FHIR value sets or a FHIR device resource. For example, a heart rate could be identified using its line code. The same thing with activity sensor data that's coming out through core location, core motion. Using active tasks from ResearchKit can have its own codified system, which can be identified within the FHIR resource. With that in mind, Smart Markers thus uses this Smart on FHIR specification to be interoperable and substitutable across all compliant EHRs and, of course, FHIR servers. This is a framework to create PGHD apps for practitioners and patients. It captures not only surveys, but also data from mobile phones and apps that use device sensors through some third-party web services like Omron. The single framework can be used to create apps for tablets, phones, and web apps, and it's all completely open source on GitHub. Let's talk a little bit about standards. We comply with all necessary implementation recommendations that have come out in the last couple of years. Of course, FHIR and SMART are already there, but the ONC, which is an HHA's entity, actually produced a PRO implementation guide that we certainly comply with. And we have a common session UI model, and all surveys are actually done through the questionnaire and the questionnaire response structure. But this is only limited to questionnaires. There might be other instruments that do not need a survey model. So in that case, we use different FHIR resources. For practitioner apps, as I've said earlier, apps can be built for point-of-care use. They could be tablet apps for waiting rooms and for inpatient data collection. That is usually common in pre-op and post-op wards where practitioners want to see or get survey for any symptom or functional status of that patient pre-surgery and post-surgery. And in the modules, we actually have a way to dispatch those requests to the patients. The different kinds of instruments that are available through that institution can be listed. There are methods for that. And then the framework also includes modules that can fetch historical patient responses related to whatever that was requested. And the returned objects could be FHIR questionnaire response or observation. This is a normal workflow that we actually published early last year. With Smart Markers, any app, once it is produced, the normal workflow is that after a practitioner selects a patient, then from a drop-down list, they select a PGHD instrument, which could be a questionnaire, it could be an identified LOINC code, which could look up step counts or heart rate or blood pressure. Then you can attach or associate a certain schedule, which means that a practitioner can request that instrument to be administered either instantly or weekly once, twice, monthly once for a limited period of time. And then that whole information is embedded within the FHIR service request, which is then dispatched back to the FHIR server. That was a normal practitioner's workflow, highly simplified, of course. This is the same framework that can be used to create patient-facing apps. And in this case, all patient apps have the capability to respond to the PGHD requests that were made by their care team. or they can actually voluntarily submit their generated data using the same model. For their workflow, after there's a Smart on Fire login, the patients get a list of requests. Then they resolve what kind of instrument was within those requests, and that could be a survey or a request to send some heart rate. Then they have an on-device instrument session rendering and administration, which means at certain intervals, whenever that request approves, the patients can undergo that session on their device and actually generate some data. And then once those data are generated, we combine them within a FHIR submissions bundle, have a patient consent, and then send it back to the server. This is the underlying data model that is used for the patients. And this is a little specific to FHIR. Obviously, you may have noticed everything that is IO is essentially FHIR. All the requests are in the FHIR service request resource. The instruments can be questionnaire. It could be a code. It could be a value set. It could be a device. The session interface that generates some data that is results is also FHIR, which is a questionnaire response or an observation or a media that had that is the result of that session. And the submissions module finally is responsible to send all that data back to the FHIR server. Looking at the screenshots should be very familiar to the folks who are watching this. This is very much using ResearchKit. We actually use the same UI layer that is used by many different apps. But we have built-in modules that transform all the FHIR embeddings into a ResearchKit-based session. So the FHIR questionnaires are ResearchKit survey sessions. Once initiated, they complete. After completion, there is a report submission module that is also a ResearchKit survey, but it actually asks whether the generated FHIR data should be submitted or not. Of course, with consent, it is finally submitted. So it is a common theme no matter what instrument was requested. The same model is applied for data to fetch heart rate or activity, or having the user go through their Omron repo to fetch their blood pressure, have it packaged into FHIR observation, and have it pushed out to their care team. Now, we have a list of PGHD instruments. A lot of these are support for creating survey sessions for FHIR questionnaires and adaptive dynamic questionnaires from PROMIS, which is actually an NIH's relatively new effort to adopt and standardize surveys across the country. It's actually being used by a number of hospitals across the country today. And there are certain device-based measurements. These were made available through the ResearchKit module. We ended up transforming the results of these survey sessions, like Amsler grid, 9-peg hole, range of motions, and have it yield FHIR resources which are compatible with it. The Amsler grid result is packaged as a FHIR media resource. The range of motions are packaged as FHIR observations. The same goes with the others, contingent on whatever data type it was. We generate the corresponding FHIR resource so that any kind of output is essentially FHIR. So you're hearing a lot of FHIR here, obviously. Then there are also ways to get data from the Omron repository, which can happen in-app within the survey generating module. There are ways to fetch data from the Apple Watch. Apple Health Medical Records is a new feature which Ricky talked about earlier this week. And they have APIs available where apps could request the FHIR clinical health record data that iOS's health app already has. And there are modules within Smart Markers where that process is streamlined as well. So in a summary, Smart Markers is essentially a framework for apps. All functionality is abstracted into a common framework. It enables turnkey customized deployment of PGHD functionality, both for practitioner-facing apps and patient-facing apps. I do want to make a note that you do not need to make both these apps to have this functional. As you know, that both these are detached functionalities. There could very well be a research-focused app that only is responsible for sending data back to the server without having being received any kind of request from their care team. This is all open source, github.com/smartmarkers. Please, we are looking for sites who would want to use this, and we want to experiment as much as we can, and we are looking for suggestions. So please feel free to get on it and open up issues, and I'm happy to discuss this on the Discord channel as well. This is for our experience, and we presented this at AMIA conference 2 years ago. As part of the Easy Pro project, we were able to create a specific application for the promise measures. And this was a dedicated app using the Smart Markers framework just for this. One of our teams within BCH, we worked with the neurology team to create a seizure diary. The same framework, but different UI, different implementation, but same essential functionality. Data that is being produced is all FHIR, and data that's being received is also all FHIR. So these are examples of how the same framework could be used to essentially create your own UI, which only developers really know what would be best for them. So the framework itself is embedded with functionality and methods, but the UI part, developers are free to use whatever that they want, essentially. I know that a lot of people talked about in Discord about iOS, seeing that this is a lot of iOS heavy stuff, but that's not the case. We have a React Native version that is also on our GitHub page. This is an early beta version of that is compatible with both iOS and Android, and we have essentially built the same pieces along the same principles, and we have support for FHIR questionnaires and promise questionnaires for this. But the same thing applies. The same React library could be used to create practitioner apps. It could be used to create patient-facing Android apps. So that was a little technical architecture. I do have posted videos in our Discord channel with going technically into how you can program in Xcode and create a simple PGHD app using Smart Markers. So please look forward to look into our channel on Discord. Having said that, taking an overview, there are certain challenges today having a system like this to be implemented across the health systems. We are looking at various ways of how this is deployable, not just today, but in the coming years as well, where practically every endpoint that has anything to do with healthcare will possibly have a FHIR server associated with it. But as of today, EHRs have extended limited write capabilities, but there's lots of interest, and actually some efforts within the Argonaut are actually going on to try to see whether the EHRs can extend write capabilities for third-party applications. The ONC PRO guidelines are FHIR version 4, so please make sure that whatever FHIR version that you're using, most likely it should be 4, because most of the EHRs are moving in that direction, and most of the FHIR servers today are also R4. But I also think today in practice, everything is R2. But if you're looking for a forward-looking new app that can do amazing things, so please look out for FHIR R4. It is a little more advanced, has a bunch of more resources, and a lot could be done with it. Some of the approaches that we have proposed and we are working towards is to use smart markers with cloud fire services. And we know that most of the major cloud vendors now have a fire managed service. So smart markers should be compatible with almost all of those fire services. All of them support R4. All of them may, or even if they don't have a layer of smart, they do have a layer of the RESTful APIs that we actually crucially need. So it should be able to work with Google's Fire Healthcare APIs or Amazon's Healthy Lake or even custom virtual machines that have some Smile CDRs, Fire. I believe that is the Happy Fire server. So practically any endpoint that is Fire enabled should be able to work with smart markers. Lastly, please look us up on GitHub and look us up on our Discord channel, as Aditi mentioned. And please, I have posted the Slack invite channel, invite link actually in the Discord channel. So please look us up or just send us an email and we'd be happy to have this conversation further. Thank you very much. And back to Aditi.
Perfect. Thank you so much, Rahil. That was very, very helpful. And then he's also Rahil, you're hanging out in Discord, right? Just to answer some questions.
Yes.
There are questions already there for you. I'll let you kind of address them offline. All right. Thank you again for being with us today. All right, everybody. So I'm signing off for now. I'll be hanging out on Discord if you need to get a hold of me, and I will see you tomorrow at the closing ceremony. So see you tomorrow. Bye.